Physicist Dr. John Brandenburg is joining us again. He will be discussing the hypothesis that ancient Mars suffered a bizarre nuclear accident, as indicated by samples of argon and xenon isotopes detected across the planet's surface. John suggests that the prevalence and balance of those isotopes is consistent with artificially generated nuclear activity, and he explores various scenarios that could lead to the creation of this evidence. So, John, let me see. Are you with us, sir?
Pardon me, a little rusty on this. Yes, here I am.
Perfect. Thank you, sir. Thank you.
So disclaimer by saying that this is my opinion. Yes, it's my hypothesis. Everybody knows what a hypothesis is, apparently, except the legal department. So anyway, the title of my talk is Evidence for Past Nuclear Explosions on Mars. I consider this to be an important piece of information about the universe for the human race at this point in time. Okay, this is of course our planet. You go into the solar system, you'll spot this planet immediately because it's covered with water. And the presence of liquid water basically says life environments, at least for Earth-like life. Okay, now the first Earth-like planet in the rest of the cosmos was Mars, and still is Mars. I mean, it's more Earth-like than any other planet in the solar system, and apparently was much more like Earth in the past. Okay, so I'll be talking about Tesla and Mars very quickly. Mariner 9 and its Zeitgeist, meaning the spirit of the times. Viking and Cydonia, reconstructing the past climate of Mars. Mars polar lander results. New Mars synthesis, taking together all the Mars data from the meteorites and landers and orbiters and putting it into a new picture of Mars in the past. New images of Cydonia and Utopia, and then what destroyed Mars? What made Mars what it is today from a planet which apparently was very Earth-like in the past? Okay, in 1901, about the same time that Lowell was doing his work on the Mars canals, Tesla got all the governments around the Earth to go radio silent so he could listen to signals from Mars, and he believes he picked up some. Now, I wasn't there. I don't know what his data looked like, but he insisted that he had received signals from Mars indicating technical civilization there. Now, this is part of the search for extraterrestrial intelligence. Here we are in our here we are in the galaxy. Nothing could be more average than where we are in the universe. We're in an average spiral galaxy. We're in an average place in that galaxy. And this is in keeping with what's called the principle of mediocrity, which mediocrity means average. We're C students. We're not an aberration on the cosmos, though some people would like to think we are. We can always do better. But mediocrity says that if you want to know what Earth-like, intelligent beings in the universe, intelligent civilizations and life environments look like, just look around you. We're average. This leads immediately to the feeling that we are not alone in the universe. And there's more and more evidence that life environments like Earth are very common in the universe. Every star, except for a few oddballs, apparently has a family of planets, just like hens and chicks. Question is, how many other civilizations occupy the galaxy, or how far would we have to go to find signs of civilization, past or present, on another planet? Do we have to go light years? Do we have to go light minutes? Well, in 1970, Mars, which had always been the object of great fascination since the Victorian era, became the focus of a bunch of Mars probes. And the Zeitgeist of the time, the spirit of the times, held that Lowell's canals and Tesla's signals suggested that Mars had been inhabited. And this was a very persistent thought, not only among the public, even if the science community rejected it, but among the government officials. Remember, the government officials listen to scientists all day, especially when they're asking for money. And unfortunately, they know science and its foibles. They don't believe everything that scientists say, especially when they're projecting miraculous results. And so there was a certain amount of skepticism for mainstream science rejection that Mars could have been inhabited in the past. So despite new probe data in the 60s, the Lowellian view of Mars persisted. For one thing, when they first got to Mars with probes, they found a bunch of craters like the moon. But then they also realized that, gee, Mars has a lot less craters than it should have if it was moon-like. Then in 1970, Mariner 9 went into orbit around Mars and found past Mars water channels, indicating an Earth-like climate in the past. Liquid water defines what an Earth-like climate is. And thoughts of a dead civilization on Mars were renewed. They were especially renewed because of some of the things they found there. Von Braun suggested perhaps archaeologists should be the earliest humans sent to Mars. And von Braun was certainly in the loop at NASA. Now, what they also witnessed at Mars on Mariner 9 was a global dust storm that covered the planet from pole to pole. This led to the mission almost failing because the mission had to kind of mothball itself in orbit around Mars. But it survived just fine. But it helped end the Cold War because people realized that this global dust storm could happen on Earth in the aftermath of a nuclear war. So Mariner 9 survived the Great Dust Storm, and it mapped the Mars total surface to about 2-kilometer resolution. Then it took high-resolution images of about 1% of the Mars surface, and it discovered a Great Canyon system, the Valles Marineris, and extinct water channels. And some of the water channels indicated from their form that they had flowed a long time, and they were on lightly cratered terrain on Mars, indicating young terrains. So this indicated that Mars had had liquid water for most of its history. We knew the older parts of Mars were covered with water channels. So were the young parts. So Mars was much more Earth-like in the past for billions of years. They also saw at Elysium what looked like pyramids. And they came back, they were so fascinated by these that they came back and took another picture of them, which was very difficult for the Mariner 9 to do, but they did it. So they took a picture at sunset and a picture at morning locally on Mars. They were about 1 kilometer high and 3 kilometers at the base. Unfortunately, Mariner 9 couldn't investigate any further on that. Then in 1976, encouraged by the water channels on old water channels on Mars, they sent the Viking to look for life in the Mars soil. They found strange chemistry in the soil, which they attributed to not to life, but to oxidation. So anyway, but these are the Viking landers, which were very successful. But the orbiters part of the mission took this picture in July 1976. At Cydonia Mensa, they got a picture of what they called the head. And it was near the prime landing site the reason they were taking such high resolution pictures of that area of Mars because it was Cydonia and they wanted to land at Cydonia. This was then changed. This mission objective was then changed. They also said that they took a picture an hour later of the Mars face and it didn't show anything. That wasn't true. There was no picture an hour later because it was nighttime had fallen on Mars. They took the head picture on at local sundown when the shadows are longest and shows the most relief. They waited till everybody had quit talking about it, which they did, and they waited for 30 days. Then they came back and imaged it a second time in the mid-afternoon. And this is what the picture at mid-afternoon shows. It shows it is a face-looking object, and also immediately noticed was a pyramid. This had been visible in the original picture, but no one noticed it. So, but DePietro and Molinar, who were investigating, found this picture and identified the pyramid. Pyramid is, the head is about 2 kilometers wide on the side, 1 kilometer tall. Actually, it's more like half a kilometer tall, pardon me. And the pyramid, though, is about 3 kilometers on the side and 1 kilometer tall, like the pyramids of Elysium. So this led to people thinking, well, what on earth looks like this? Well, the Olmecs, a very mysterious civilization in Central America that predated the Mayans, carved a bunch of heads like that. And of course, there's the Sphinx in Egypt. Now, this is what the Sphinx originally looked like. They've dressed it up a little bit. Any archaeology on Earth will suffer erosion. The same planetary environment allows life on Earth: rain, sun, moon, cycles of the seasons. Winds creates erosion. And also, so it erodes the artifacts of civilization that we create here on Earth. It would do the same on Mars. Ancient Mars looked like this, apparently. And by the way, the Mars ocean was discovered in the process of examining the pictures at Cydonia Mensa. It became apparent it would look like it was on the shore of an ancient ocean. And I was the first person to give a paper on that. I don't get any credit because of my connection to Cydonia. But that's what Mars used to look like. So how long did Mars and Earth share similar climates? I wanted to mention also that the ocean lay on the youngest part of Mars, the most lightly cratered. When you don't know the age of a planetary surface, you count craters and estimate the cratering flux relative to the moon, where we have rock samples from specific areas on the moon of a certain age. And what you find is that the more craters, the older the terrain is. So on Mars, the southern half of Mars is heavily cratered. Apparently it was a desert for most of its history. And the craters have been preserved from almost the foundation of the planet. But in the north, there was a lot of geologic processes, a lot of erosion, a lot of volcanoes, and the craters are actually very sparse, and that's where the ocean bed is. So that means that Mars ocean lasted for most of its history geologically. Okay, so how long did Mars, Earth, and share similar climates? Did Mars have life? Well, I think at this point, if Mars had an Earth-like environment, it certainly had life. We've found now fossil life on Earth dating from 4.2 billion years ago, almost as soon as the Earth had an ocean. So, and it didn't come from the primordial soup involving the first single cell with the enzyme systems and DNA and stuff like this. It was probably panspermic. So did Mars have life? Most certainly. It probably got life on it from the same place that Earth got it, from space. Did Mars' Earth-like climate persist long enough for modelized life to evolve? Yes, apparently it did, because the ocean on Mars, which is the signature of Earth-like climate, apparently persisted until late in Mars history. Mars is 4.5 billion years old, the same as the Earth. This ocean apparently lasted for at least 4 billion years. What level of complexity did Mars life reach? Here's the Paleo ocean of Mars, first proposed by myself in 1986 to an audience consisting of about 1,000 Mars scientists, none of whom can seem to remember that I gave this paper. I know my tribe, unfortunately, the tribe of scientists. Mars polar lander lands on the old ocean bed. Water and ice is found right under the surface. The soil can support life. It's got plenty of water. Soil is consistent with an old ocean bed. It's even salty. Old Mars ocean hypothesis is confirmed. Now, Mars, as it turns out, it was rather accident prone. It's right next to the asteroid belt. Here's, by the way, you can see the transition in terrain from here's where the ocean was, here's where the shoreline was, and of course, here's the highlands. And right on the boundary of the ocean, apparently this impact happened. It was as big as the one dinosaur annihilating Chicxulub impact on Earth. It would have changed Mars climate. It probably just came from the asteroid belt. What it did apparently was if you look at the rate of water erosion that could be estimated from the pictures, apparently in this epoch, Mars lost a lot of, Mars went into a deep freeze, but then it recovered. So Mars had a kind of its own Chicxulub impact, but apparently recovered and was eroding stuff with liquid water again. From this, you conclude that because of Mars' location near the asteroid belt, it was accident prone. So you can gather all this data together. We have all these Mars meteorites. We have all this orbiter data and pictures. We have all of these rovers roving around sampling things. It looks like Mars cratering rate is about 4 times what the lunar rate is, considering that Mars is next to the asteroid belt. That's reasonable. Mars apparently had a persistent CO2 greenhouse plus methane greenhouse, like Venus, for about 4 billion years. The greenhouse was stabilized by the Northern Ocean and oxygen. As it turns out, if you put up a CO2 greenhouse, the CO2 carbonic acid will start combining with the rocks, except if there's an oxygen atmosphere, like on Earth. Then the rocks oxidize and release the CO2 back into the atmosphere. So you can have a stable, chemically stable greenhouse, carbon dioxide greenhouse if you have a strong oxygen component in the atmosphere. Mars apparently had life long enough to have biological evolution like on Earth. Whoops, pardon me. Mars greenhouse destroyed by a LEO impact, causing mass extinction, but it apparently recovered. Then something else happened to turn Mars into Mars, the Mars we know today from being a planet that looked like Earth. It was apparently some sort of nuclear catastrophe. Now, why did Mars die? What was the cause to turn Mars into Mars? Well, there's evidence of massive thermonuclear explosions on Mars 180 million years ago. When I originally discovered the isotopic data, I thought it might be a bunch of large natural nuclear reactors that went unstable and exploded and caused Mars to lose its atmosphere. We had natural nuclear reactors on Earth. This was actually a well-received idea when I presented it at the Planetary Science Conference down in Houston. The evidence was a Xenon 129 spike in the atmosphere. Rocks the Mars meteorites we got apparently were bombarded by an intense neutron bombardment, turning a lot of the bromine 79 into krypton 80, which is a gas. Bromine is a liquid, or would have been bound in the rocks, but it released this inert gas, krypton 80. And there's a lot of evidence for, so an intense neutron bombardment late in the Mars history, about 180 million years ago, which is a blink of an eye in terms of geologic time. And the thorium potassium scars. Potassium becomes radioactive when it's bombarded by neutrons, and thorium is naturally partly radioactive, So it can be, Mars atmosphere is so thin, you can actually orbit a gamma ray spectrometer around Mars and figure out what the rocks are made of by getting the gamma rays out of them through the atmosphere. Now, here is the first sore thumb at Mars. This is the abundance in the atmosphere relative to Xenon 130. And it shows that the blue line is Earth, where Xenon 129 and Xenon 132 are roughly equal. Those are the two most abundant Mars xenon isotopes. So Mars and Earth match pretty well, except at Xenon 129, where Mars has this superabundance. Now we've probed the Mars, the atmosphere of Jupiter. We have Earth. We have the solar wind. We have Mars. We have a lot of meteorites. All of them show Xenon 129, Xenon 132 to be roughly average, except for a few oddballs, which I'll talk about in a minute. So what is the explanation in the planetary community for the Xenon 129 problem, they call it? Well, it turns out it's a coupled problem, because when the theory of the formation of the solar system was that it was formed in the aftermath of a supernova explosion, just about the same place we are now. And so the solar system was kind of born radioactive. And it had a lot of unstable elements. One of them was iodine 129, which has about a 15 million year half-life. And then, so it decays into Xenon 129. We see that on Earth as a result of nuclear tests. However, another component of this is what's called plutonium 244. It's a very rare, it's not any good for nuclear weapons because it's so stable, but it's the most stable form of plutonium. It has a half-life of 80 million years. And when it decays, it produces a lot of Xenon 132. On Earth, Jupiter, and the Sun, apparently those two, the iodine 129 and the plutonium 244, create a balance between Xenon 129 and Xenon 132. That's average and normal. The mainstream view was that Mars lost its atmosphere early, and the iodine 129 trapped in the rocks then turned into Xenon 129 and filled up the atmosphere and produced this excess. But the problem is that they don't find any trace of the plutonium 244 decay products, which is principally Xenon 132. That's gone. So they have, and its half-life is so similar to Xenon in geologic timescales, 15 million versus 80 million, and it would have followed after. So there could have been a momentarily increase in Xenon 129 in the atmosphere, but it would have been, done away with by the decay of plutonium 244. So this is a big problem. The other big problem with this model which kind of assumes that Mars' atmosphere has always been thin, is that early Mars atmosphere was dense and wet and was largely retained. There's water channels all through the southern part of Mars, which is heavily cratered, and up to the north. So Mars not only had liquid water and a dense atmosphere, which is required for liquid water from the very beginning, but it also lasted for most of Mars' history. There's no evidence for Mars losing its atmosphere early and not regaining it. Now, there's a process called R process, meaning R for rapid, means rapid, intense bombardment by neutrons, by high energy neutrons. And if you compare Earth and Mars with the R process xenon products, which are worked out in simulations for supernovas, you find that the xenon 129 spike is reproduced. So there's a competing process, which is like, it's called the slow process, and occurs in ordinary stars or nuclear reactors that use thermal neutrons. And it hardly produces any xenon 129. It favors the heavier xenons, xenon 132, etc. So the slow process produces almost no xenon 129 relative to 132. But the R process, the rapid process, produces the xenon 129 spike versus 132. So xenon 129 abundance in the atmosphere over the abundance of xenon 132 greater than 1. That's the signature of the R process, and that's in the literature. It's in the literature from supernova simulations. Now, there are only two known places where we know of that produce R process events. One is a supernova. If there was a supernova on Mars, it would have blown the planet to pieces. We wouldn't have a solar system. However, you see R process in thermonuclear explosions. In fact, they use some of the same codes to simulate supernovas and nuclear weapons. When I was at Livermore, that was done. So we now know where the 129 excess came from. It came from an R process event. At least that is the only known process that can produce the Mars xenon excess. Also, Krypton 80 over Krypton 84 is enhanced 10% over solar nebula baseline. Xenon 80 is believed to be generated by neutron capture on bromine 79. Bromine is a toxic element similar to chlorine, and it's bound in the rocks. But if it gets hit by neutrons, it turns into Krypton 80, which is inert gas, which slowly works its way out of the stones into the atmosphere. So a neutron fluence of 10 to the 15th centimeters per centimeter squared is required on Mars rock. They had to put rocks in nuclear reactors to simulate, to find results that were similar to what they were seeing in the Mars meteorites from 180 million years ago on Mars. So one of the first identified Mars meteorites, Mars meteorite ETA 7901, shows abundant evidence of this Mars neutron bombardment. And that was late in Mars history and geologic time. Now, there's some other interesting things. Mars, such neutron fluence would have also activated the potassium in the rocks. Now, Mars has less potassium than Earth by about a factor of 10 to 3 in the Mars rocks. Yet there's these two hotspots on Mars where there's a lot of radioactive potassium. And not only that, it looks like it's consistent with kind of a neutron generating event here, an explosion that created shock waves that wrapped all the way around the planet and created a deposit at the antipode on Mars from the explosion. If you look at Mars thorium, the same pattern persists. Though it's slightly shifted, there's a hot spot and then an antipode deposit. So it looks like something, this neutron event happened here, caused shock waves all the way around the planet, and they ended up at the antipode. Now, I spent about 10 years at nuclear weapons design laboratories, Lawrence Livermore and Sandia Labs. I didn't work directly on nuclear weapons. I worked down the hall from the people who invented the neutron bomb. That was really something. But I worked on controlled fusion. But thermonuclear weapons have a fission trigger consisting of plutonium, generally plutonium atomic bomb, which then fills a casing with radiation, which then implodes a hydrogen-rich secondary, which then creates the hydrogen reaction. So it starts out being fission and then fusion. Then the casing and what's called the tamper are made out of uranium or thorium. In the case of the W-71 Canakin space warhead, 5 megatons, the casing was made out of thorium. They declassified that in 2008. And this, even though that uranium is 238, or the thorium is not susceptible to making an atomic bomb out of, it's the wrong type of isotope. The high energy neutrons from the fusion split those nuclei, and they boost the power of the hydrogen bomb by about a factor of 2. So a modern hydrogen bomb goes fission, and then fusion, and then fission of the casing, which can be made of uranium or thorium or a mixture of the two. Now, if you look at the amount of potassium in the Mars rocks that we've received, the Mars meteorites, they all have very little potassium in them. They're down here, and they all have very little thorium, except on Mars, on the surface, there's a lot of thorium and a lot of radioactive potassium. So that indicates, how can the surface of the planet be more radioactive than the rocks from subsurface, which are the Mars meteorites? They were believed to have been subsurface rocks blown to Earth by impacts from the asteroid belt. Well, if you had a big nuclear explosion on Mars, especially if it was an airburst, that would do it. Here are these hypothetical, here are the sites of these hypothetical nuclear explosions. One was in Mare Acidalium, upwind of Cydonia Mensa, would have carried the shock waves, and also the fallout most prominently to Cydonia Mensa. There was a smaller nuclear explosion, the other hotspot, at a place near, it was upwind of Galaxis, a place called Galaxis Chaos. I'll be showing you pictures from there. And there are no craters in these hotspots. They're almost completely uncratered. This indicates that there couldn't have been an underground natural nuclear reactor that went unstable. It has to have been an airburst in midair, several kilometers up, so that it didn't create any craters on the surface. Now, if you look at Galaxis Chaos, or what is also called Utopia, because you see, for one thing, the pictures from Viking, there's a watermark on the lens. Here's some what look like ruins. And we're going to focus in, though, on these two objects here. Galaxis Chaos shows what apparently are two fake carved faces into the Mars landscape. And the second one, the lower one, is kind of low relief, so it disappears at certain sun angles. But the overall structure of the face is revealed in lower resolution pictures. And it looks very similar to the Cydonia face. It's about 2/3 the size of it. This is large. And it's now been found in multiple pictures. If you do a detailed comparison between the Viking pictures for the Utopia face versus the Utopia upper face versus the Cydonia face, you find they both seem to have cheek ornaments, a helmet, and an indentation over the left eye, or the right eye rather. Anyway, now in 1998, with great fanfare, the US government took a new picture of the face on Mars. This is what they released, unenhanced, uncorrected for, you notice the crater is elliptical, not round, indicating they're not taking this picture from above the face, they're taking it from the side. Here's an enhanced version due to Mark Carlotto. And you can see there are ornaments on the helmet, and there's nostrils in the nose. Then there's eyes, mouth, nose, mouth, helmet. It's all there. Dr. Carlotto was also able to use a three-dimensional model of the Cydonia face based on the Viking pictures and a shape from shading algorithm to then stretch the new image over that three-dimensional model and rotate it so we could see what it would look like from above. It looks like the Lion Man from Wizard of Oz. And you can see there are clearly two nostrils in the nose and more details on the helmet. Now, we've been taking a lot of pictures of this thing, and the nostrils have been confirmed in some of these new pictures. Here's Mars Odyssey, 2001. That's under control of University of Phoenix, and therefore didn't go through JPL, and they could release whatever pictures they wanted, the way they wanted them. And they took pictures of the face on Mars. Here's you can see there's a circular crater beside the face. That means you're taking a picture from straight above, like the original Viking pictures. And you can see the face is there, so is the pyramid. It's all the same. Now, one of the things that happened is in the new images, we have higher resolution pictures of the pyramid. It apparently has what looked like a square doorway. Well, actually, no, it looks like a place where a bunch of bricks have collapsed off the face. And you can see that clearly in the new pictures of enlargements of the new pictures of the pyramid. And once again, we have in recent Odyssey images over and over the same structures we saw in 1976. Now, they've also re-imaged the face at Galaxis Chaos, or Utopia, as they call it. Here's the Odyssey picture. Here is the Viking picture. As you can see, it is looks like a face and a helmet. And all of the details are there that were originally identified from the Viking picture. They've also taken them now with the Mars Reconnaissance Orbiter, a different sun angle. It looks like the part of the face may have split and sunk. So you can't see it from above, but from the side. But if you zoom in, because the high MRO images are so precise, you can see that around the nose, there are symmetric nose ornaments. So we published a hypothesis in 1991 based on the Viking data that Mars had Earth-like climate, life, and evolution. Mars developed humanoid indigenous level of civilization, approximately Bronze Age level of technology. We don't know its level of technology. All we know is we see some massive ruins. It'll take a detailed investigation with boots on the ground to figure out what its real level of civilization was. The sites of the civilization were located near the shoreline of an ancient Northern Ocean. The civilization was wiped out by planetary catastrophe and consequent Mars system climate collapse. Now, based on the new images since Viking, it's been confirmed. Sidonian hypothesis, despite erosion of the objects, is confirmed by the new images. We see symmetric details, nostrils in the nose of the Cydonia face, which is the larger face, possible collapsed brickwork found on the pyramid. So friends, we're staring at a dead civilization on Mars. It is my opinion. So now, why did Mars die? Mars was like Earth for a long period. It survived apparently several traumatic events relative to impacts from the nearby asteroid belt, but still managed to have life and civilization occurring there, leading to a primitive humanoid civilization. At least it looks primitive. We don't know what its real technological level was. And by the way, this civilization apparently perished 180 million years ago, long, long time. That was before even the dinosaurs were on Earth. So I don't think there's any connection between the Mars civilization and Earth civilization, except maybe through the collective unconscious, Jungian's collective unconscious or something. For unknown reasons, Mars apparently was attacked by thermonuclear weapons from space. These were massive nuclear weapons as big as the Empire State Building. They were dropped from space. They went off as airbursts because that causes maximum shockwave damage to small structures on Earth. The only reason you use a nuclear weapon with a ground burst is if you're trying to destroy underground structures, but they were apparently aiming for the above ground structures. They would be susceptible to a magnified shock wave from an airburst. The attack destroyed Mars' biosphere. Not only did it kill the civilization, it killed all of Mars and left so much radiation that Mars would never recover as a biosphere. There's probably a tattered remnant of bacterial life on Mars. There are many signs of that, which I won't go into here. But friends, therefore you are not alone in the universe. And not only that, you didn't have to go very far to find a humanoid civilization. You go out to the next planet, next Earth-like planet, and apparently there are remnants of one. And there's also remnants of a horrific tragedy. What does this all mean? Well, it means you aren't in Kansas anymore. In fact, you come to realize that Kansas was stuck right in the middle of Oz, a small island of the familiar in a sea of strangeness. You're not in Kansas anymore. You're actually in a dive bar in Mos Eisley Spaceport. But as Obi-Wan Kenobi said, but watch your step. This place can get a bit rough. The real location of Kansas is shown here on this simulated map of our galaxy. The rest of the universe is like Earth. If you want to know what intelligent life in the universe acts like, turn on the news, particularly now. The government has known this since 1976, apparently, and has faced up to it. You will too. So the hypothesis, a dead civilization on Mars has been discovered and kept a secret by the government. In 1976, we're in the middle of the Cold War. I understand why they would do that. It was a bad shock. It would have been a bad shock. The civilization was humanoid. It was destroyed by a nuclear attack. The same thing could happen to us. Technological level of civilization appears low, but is unknown. This discovery is of great strategic importance. The nation that is the first to explore those ruins will establish itself as the supreme space power. Access to the ruins is the hidden driver of the American Mars effort and the effort of other nations now. Data released to build public interest in Mars without confirming anything. Now, this is what I believe the future will look like. Hey, I grew up on Star Trek. I would not have any problem with living in the Star Trek universe. Mars tells us that universe is like Earth, both good and bad, just like on Star Trek. Not only did you have the Vulcans and the Andorians and the other members of the Federation, but you had the Klingons and the Romulans. The future of human space exploration is bright if we are diligent and persistent. Whoever did what they did hypothetically on Mars is long gone. However, the same thing could happen to us, particularly if NASA keeps beaming messages out into Mars, out into space, saying the welcome mat is out, all ETs come here and visit. A dead civilization on Mars and its demise may be disturbing to humanity, but for us in the space community, particularly the ones who know we're not alone in the universe, this is good for business. And I say that in the sense that we will be seen as the frontier trailblazers, which is always nice. Humanity is part of a living cosmos, and we must boldly go forth and find our destiny in it. And don't worry, the force will be with us. Got to be an optimist. This is Kepler Aerospace's view of the future. We hope to be establishing moon bases 20 years from now, or maybe even sooner. Thank you very much. And now yield the floor back to our moderator.
Well, John, let me do this. Okay, yeah, stop your screen share, and I want to put this thing on gallery view. Everyone, please give an enormous applause for Dr. John Brandenburg. John, thank you so much. Thank you for your patience.
It's a great honor to be addressing you all.
Thank you for your patience with the technical issues. Thank you to everybody in the audience too.